everyone! Today we'll be doing a quick tutorial on how to make a couple different kinds of plots in R. So for starters, you're going to want to grab the datasets that you want to use. My datasets are all in Excel files, so for starters, you're going to have to tell R to read Excel files. So you're going to start with library, read Excel, run. Real quick, simple command. Next, slide over here to import dataset from Excel. You're going to slide over to Browse. I have 3 different data files for each of the different kinds of plots we'll be going over today. So just Browse, Open, Browse, Open, Browse, Open. And it gives a little nice preview so that you can make sure that this is the data file that you want to use once you open each one, and it appears over here. So we're going to do that for all 3 of my data files. It's taking a second to open a couple of them, but no biggie. Just making sure all of them are the appropriate data files that we want to use. Excel, Browse, this is the last one. Grab up this last piece, open, and import. So once you have your data files up, you can go back into the main R window, and because I'm working with 3 different data files, I want to tell R which ones I'm working with first. So I'm going to go with the attach command and type in lesson 26 data file 1, which means, hey R, this is the data file that I want to use real quick, so you should prime that for me. So we're going to hit run. And this is because a lot of my variables are the same between data file 1 and data file 1 prime. So, no worries. Because I don't want to keep saying lesson 26 data file 1, lesson 33 data file 1, etc., I'm going to rename the variables because I'm going to be using these a couple different times. The dataset names. So in order to do that, you just type in the name that you want to change it to, give it a push command, and the source. So we're going to change lesson 26 data file 1 to data p2, just an arbitrary name, I know what it means, and we see that it appears in the data view over here, and we're going to do the same thing with data p13 from lesson 33 data file 1. And the reason why I only did it with these 2 and not with data file 1 prime is because I only use data file prime 1 time, so there's no need to give it a nickname, it's just extra work. So, first plot we're going to go over will be a scatter plot. So we have plot, data p13, which is this data file up here, and when we use the $, we tell R to go into this data file and grab this variable. So we're going to do the variable for quad strength, and that'll be Rx. Then we're going to do the same thing, so data file, same data file, $ injury, and that'll be frequency of injury over a period of 5 years. That'll be our second variable, that'll be our dependent Y variable. So that makes the plot, but the plot needs labels and names and graphics, so these will be the next couple commands that we do. So you have main, quad strength preventing injury. Main command basically creates the title of the graph. xlab or xlabel will label your x-axis. You type out what you want it to label that as. I chose quad strength. ylabel, same thing. Injuries over 5 years. So this will be my x-axis, this will be my y-axis name. And pch17 is the icon that the scatter plot uses for each of your data points, and we can change those however we want. So for example 27 changes it to, it's not a command, but if we were to do 24 it would be open triangles. So let's kick it back to 17, and so that's how you have your scatter plot. You have your title, the y-axis, injuries over 5 years, and quad strength. So we were trying to see if quad strength predicted the frequency of injury over 5 years. It's a pretty patternless scatter plot, so it doesn't seem to. But on to the next one. For this next density comparison chart, you're going to want to make sure that R can actually run it. So you're going to want to do library sm and run, and that basically just primes R to be able to use this function. So we're going to create another condensed variable name. This one we'll call method.x. So for this set, we're going to do factor, which basically takes everything past it and condenses it into a more simplified form. So factor, and we want the factor of, it encodes the parameters of a variable basically. So we're going to take factor from dataset P2, so lesson 26 data file 1, and we're going to grab the variable method. Now method is a categorical variable and it has different levels, so we're going to specify what levels we want it to grab using levels and then the C, which tells it these values in this sequence. So we're going to do levels 1, 2, and 3, and each of these levels corresponds with a specific label, and so in order to name those, we use labels equals C. So the sequence, once again, note-taking 1, note-taking 2, and control. So by doing this, we are telling R that method x is the variable that has 3 levels, and these are the label names for each of the levels. And so we're going to just run that real quick. Nothing happens over here, but it basically allows us to see that it's been done down here. Next, we're going to make the actual chart. So we're going to do sm.density.compare to create a density comparison chart. Using the same data table, we're going to tell it to grab the variable for GPA improvement, as well as grab the variable for method. Now notice this isn't method.x that we created above here. This is the original method. So we're going to run this, and we're going to label the x-axis GPA improvement using this xlab tab. So this chart basically tries to see if different note-taking methods affect different levels of GPA improvement. But as you can see from this chart, there's a lot of things missing from the chart. So the next couple of commands will fix it. So your title command will give it a title. So title main, which tells it to insert a title. GPA improvement by method, so the main label, GPA improvement by method is what we'll call it for now. Run that, and as you can see, it appears over here. Color fill, and so the sequence, we basically want it to color these lines. So 3 lines, 3 plus length, levels of method X. So we want each of the lines to be a different color. And so we're going to run that. And finally, we need a legend to tell us what line is what. We can't just guess or out of nowhere. A plot is pretty worthless without a legend telling us what's included. So we're going to type in legend and then the command locator, which allows us to choose where we want to put the legend in the plot. Levels, method X, so we want it to choose the levels from method X that we specified, because each of the levels were labeled and we want to make sure that they correspond with what we're using. And then the fill command will fill the legend with the color that corresponds with the box. I had to do a bit of playing around to get the proper color, but 2, 3, and 4 will correspond with red, blue, and green for the appropriate legend. So the console down here hasn't finished running yet, so there's that stop button. It's basically, hey, we're not done here. Clearly, we need to actually insert the legend, so that's what that locator function did. So now you can see we have the red matching with the red, green matching with the green, and blue matching with the blue, and the stop has disappeared. So, pretty complete density comparison graph for GPA improvement by the different note-taking methods. On to the next one. The last data set that we will use is similar to the previous one. It still focuses on note-taking methods and GPA improvement. However, we're using different variables from that data set. And because it's an entirely different data set, I'm going to want to attach it and run it just so R knows that this is the one that I want to use rather than this one. And all this orange is basically saying that, hey, you have variables with similar names and similar values. I'm going to ignore them. Cool, thanks, R. So on to the bar graph. So we're going to type in bar plot for the main command. We're going to want a table, and we want to use the variable method omega, which, just fancy name. I named that. So we want a little pizzazz in our graph, so we want to orient it horizontally. In order to do that, we do horizontal equals true. If we were to erase that and put false, or just erase that as a whole, it would orient the graph vertically. But we want some pizzazz in it, so horizontal. Then once again, main, so our main label equals number of participants by the method. So we want to see a whole lot of Facebook text. I don't even have Facebook open. So we want to see how many participants are in each method that we assign them to, or that were given to them. So that's our main title. Our label on the x-axis is the number of participants, and our label on the y-axis is the method of note-taking. So we're going to give that a run, and as you can see, we have our horizontal bar graph with method on the y-axis and x-axis with number of participants, our title, number of participants by method, and as you can see, we have a whole bunch of people in the note-taking 1 group and the least amount of people in the note-taking 3 group. Everyone's texting me. I'm so popular right now. But here's the end of the 3 plots. Have a great time.